This is Engineer Faisal Ijaz. Hope you will be fine. In this channel, I prepared detailed lectures for chemical engineers and also for associate engineers. In this channel, you will find playlists of different engineering subjects which will help you in your study, in your interviews, and also during your professional industrial life. So subscribe my channel for more videos. Hope you will be fine. This is Engineer Faisal Ijaz, and in this video I will explain an important subject, thermodynamics. In this video you will got a complete concept how that subject is beneficial for you. So some important lecture contents are available in this video. The first one is definition and concept of thermodynamics. The second one will be how thermodynamics become a science subject. The next one is scope of thermodynamics, and the fourth one is how thermodynamics is beneficial for scientists and engineers. And at the last I will explain 4 principles of thermodynamics. Definition and concept of thermodynamics. Here the 4 points are available and I will explain each point. The first one is energy. So here we study the use of energy for some industrial important processes like heating process, air conditioning process, refrigeration process, and water heating process, etc. The second point is transformation of energy. So a transformation of energy take place with the help of 3 processes. The first one is radiation, the second is conduction, and the third one is convection process, through which transformation of energy take place. The third point is feasibility of a process. So industrial process feasibility mainly based on thermodynamic consideration, because some thermodynamic laws have great influence on process engineering, mostly the first law and the second law. So for process feasibility, process must operate at or below thermodynamic limits. And the second point is to proceed a process at a reasonable rate, an optimum size of equipment is required for economic purpose. So under this feasibility of a process, some examples are here like condensation process and boiling process. The last point is equilibrium process, in which all intensive and extensive properties are constant. It's called an equilibrium process in thermodynamics. If we summarize the above points, the thermodynamic is a most fascinating branch of science, and that branch originated as a result when a man convert heat into work. How thermodynamic subject become a science subject? So it become a science subject after the development of heat engine in 18th century. Scope of thermodynamics. After development of thermodynamics into science subject, the other subjects like physical, chemical, and biological subjects are also influenced by thermodynamics. So its scope is also a broad scope. How thermodynamics is beneficial for scientists and engineers. So we can apply thermodynamic principles on simple process like pressure cooker, and also for complex process like a chemical plant. Now we talk about a complex process, how thermodynamics will apply here. So during designing of a chemical reactor, by using the principles of thermodynamics, the engineer will follow following points. The first one is he will consider least space for reactor. The second point is he will consume least energy for the reaction. The third one is convert raw material into product in least time. And the fourth one is he will follow the principles of thermodynamics for the behavior of different materials under varying conditions. Here I will explain very briefly the principles of thermodynamics. The first one is zeroth law. That law provide thermal equilibrium and also provide means of measuring temperature. According to first law of thermodynamics, it deals with conversion of energy and introduce concept of energy. According to second law, it deals with limitation on the conversion of internal energy of matter into work. And according to third law of thermodynamics, it deals with absolute zero of the entropy. You know well that thermodynamics have four laws. So these laws have a logical reasoning and they deduced from experimental results over centuries, and they enable scientists and engineers to explain most of the phenomena like solve a practical problem, predict behavior of material and system under varying conditions. And the third one is they are used to design of system like automobile, refrigerators, air conditioner.